In this video, we're going to take you through the 2017 question that came up in the exam question on stoichiometry, so calculations in chemistry. Now you'll be getting, this may be the time when you are preparing and revising for your exam, and this here is one of the trickiest, but I have to say I really enjoyed this question. It was one of the trickiest exam questions I've ever seen. So we'll take you through this. I'm going to show you my way of doing this, my way of doing these calculations. There are many, many ways of doing these. I'm going to show you my way. Now, I think my way is the best and easiest way, and it works for any question if you learn how to do this. But if you haven't seen me doing calculations by unit analysis before, so unit analysis, I strongly suggest that you go and watch my how-to videos on how to use unit analysis. Otherwise, you're going to get lost here. But if you learn how to use unit analysis, then it's the best method for approaching any of these calculation questions. All right, so this is 25 marks. So the usual, that comes for 10 minutes for 25 marks question. So go ahead, set yourself a timer. This might take us more than 10 minutes in an exam. You might have to steal some time from another question because some calculations sometimes take a little bit longer. So we'll see how it goes. All right, now there's going to be some names of stuff in here that you probably have never heard of. That's not really that's not really what's important. What's important is that the methods and the knowledge you have of how to do the calculations from other questions apply here too. It's the same idea. All right, so first of all, let's see what we're dealing with. It says here some of the blue pigment. So there's obviously some of the blue pigment azurite. So this is a chemical, and here it is down here. This is its formula, azurite. So here I'm matching from the question to the equation. So this here is the formula for azurite. So all of this stuff here is azurite. It's used by an artist in a picture that was painted in 1600, and it has changed over the years into the green malachite or malachite. I'm not sure, I've never even heard of that before I saw this question, to be honest. Malachite, and it's this formula here. Okay, so this here is malachite. Okay, so very slightly different chemicals according to these following balanced equation. All right, so the first thing we'll do, I'm going to get you to pause the video. I'm going to get you to write out this equation and then write out the ratio, the molar ratio of this reaction. Pause the video, do that now. All right, so hopefully you wrote it out, and then we wrote down the ratio here was 2 of these azurites to 1 water give you 3 malachites to 1 CO2. So that's our molar ratio. Next thing it says is analysis shows that only copper containing pigments in that painting are azurite and malachite, and that the picture now contains 3.81 grams of copper. Okay, so we have 3.81 grams of copper, and it's asking you what mass of pure azurite, so this original chemical, contains 3.81 grams of copper. Okay, so there's obviously copper in azurite. There's 3 parts copper in this whole thing here. So if we had 3.81 grams of copper in this format, how much of this whole thing must there be? Now, I'm going to give you an opportunity at this stage. If you think you know how to do that, we're going to do A part 1. And if you think you can figure that out for yourself, go ahead, pause the video and have a go at that calculation. All right, so obviously this is how the videos work. Usually then I give you some form of help at each stage. I give you another chance to pause the video and have a go at yourself. And if you need more help, then you can play it and see the next bit of help. But obviously if you can do it by yourself, then that's better. All right, so what mass of pure azurite contains 3.81 grams of copper? All right, so let's figure out. So if you weren't able to do that by yourself, let's kind of take you through the conversions that you got to do here. We've got grams of copper. That's what we're starting with, grams of Cu. We know we've got 3.8 grams of Cu. What we need to find out here is we need to find out how many moles of azurite is that. But we can't do that directly. We must first of all find out, well, if we've a certain amount of grams of copper, how many moles of copper is that? So we'll convert them to moles of copper. Now, from there, we want to go to grams of azurite. And we can't do that straight away without, first of all, converting from moles of copper to moles of azurite. Just call it Az, right? That's short for azurite. And then obviously from moles of azurite, now we can go to grams of azurite. So these are our conversions that we need to do. So again, now that I've helped you through that bit, if you weren't able to do it before, maybe you can pause the video and do this now. Okay, so hopefully you've been able to have some kind of a go at that. I'm going to take you through what I would do here. I use this method called unit analysis. And you know what that means is, first of all, before I do any calculations, I convert using the units first of all. Okay, now we set it up like this. First of all, what we need to do is start with grams of Cu. That's what we're beginning with. And we want to convert. Remember, we want to go from grams of Cu. The first conversion is to moles of Cu. So what we're going to do is we're going to take that grams of copper and we're going to multiply by a conversion factor, which is a fraction. And we're relating grams of copper with moles of copper. Now, first of all, what we want to do is we want to make sure that we can cancel out grams of copper. So notice I'm not thinking about any numbers yet. I'm just thinking about my unit. This is why it's called unit analysis. So that means I need grams of copper on the bottom like this so that it can cancel those grams. And I want to convert on the top to moles of copper. Okay. Now, I'm going to go ahead and do the next conversion here beside that one. Multiply out, set up my next fraction. Okay. So how do I go from moles of copper to moles of azurite? Set that up for me on this fraction. So I want to convert to moles of azurite. Pause the video, copy this down, and then complete this fraction here. So what goes on top, what goes on the bottom? Have a think about that, write it down. Okay, what you should have done is you should have put moles of copper on the bottom, moles of Cu to cancel with those moles, and that will convert into moles of azurite on the top. Now I'm going to go ahead and finish the whole thing in units, go from moles of azurite to grams of azurite. So set up my last conversion. Okay, and what I'm going to do is set up the fraction to convert from moles of azurite to grams of azurite. So pause the video and do that now. Okay, so what you should have done is you should have put moles of azurite on the bottom, so it cancels with those moles, and we're left with grams of azurite on top. Now notice all of the units are cancelled, okay, and we're left with grams of azurite, which is what we wanted our answer to be. So that tells us that we've got all our conversions right. We wanted our answer to be in grams of azurite. So this is looking all good. Now we need to go back and fill in the numbers. Okay, so first of all, write down how many grams of copper we started with. Pause the video, do that now. Okay, you should have seen that we began here with 3.81 grams of copper. 3.81 grams of copper. And what's the relationship between grams of copper to moles of copper? Pause the video, write down the numbers. Well, what we should know is that for every 1 mole of copper, when we look on the periodic table for this, there are 63.5 grams of copper in every 1 mole. All right, it's good so far. Now we're going to do moles of copper to moles of azurite. We've got to go back to our equation for azurite and look at, okay, we're going to ignore this too because it's not important here. That's just a molar ratio. Looking at this formula, if we have one of these whole thing, okay, we have one of the whole thing azurite, how many moles of copper is there for every 1 mole of azurite? So back over here, writing down moles of copper to moles of azurite. Okay, so hopefully you can see that if we were to have 1 mole of this thing, 1 mole, well, there would have to be 3 moles of the copper in here because there's 3 parts copper. There's 3 here, so there's 3 parts copper for every 1 part all of this. So 3 parts copper for 1 part azurite. That's the one place where I thought you might go wrong here. So if you got that right, well done. Okay, so we're going to say 3 moles of copper or 1 mole of azurite. Now we want to find out what's the relationship between moles of azurite and grams of azurite. Okay, so go from moles to grams. What do we do here? Pause the video, see can you do it. You're going to need the equation or the formula for azurite to work this out. There it is. Okay, well, of course, we know that for a mole of something, we have the molar mass in grams of, that's the amount that we have, the molar mass in grams for every mole. Okay, so what we need to do is say for 1 mole of azurite, we have the molar mass in grams of azurite. Now, this is a tricky one to figure out, okay? But there are 3 coppers, so we're going to do 63.5, which is the mass of copper times 3, because we've got 3 of them, plus 12 times 2, we've got 2 carbons, plus 16 times 6. Now, where am I getting these numbers from? Let's go check. Here's the 3 coppers, 3 times copper. Then we've got 2 times carbon and 2 times 3 oxygens, which is 6 oxygens. So that's where I'm up at so far. And now I've got 2 oxygens and 2 hydrogens. So I'm going to add these in at the end. So I'm going to do plus 2 oxygens, which is 16, 2 times 16, plus 2 times 1, which is the 2 hydrogens. So hopefully you're following what I've done there. I'm getting the MR. Now you might have done that separately and just put in the final number here. That's also fine. Now you're ready. You've got all this sum to put into your calculator. 3.81 times 1 over 63.5 times 1 over 3 times all of that over 1. Pause the video and find out what is the mass of azurite. All right, so hopefully that was enough time. If not, you need to pause the video. I want you to have a good go at this yourself. Okay, this is the correct answer. What you should have got is 6.89 grams of azurite. So that's the correct answer. Superb. If you got that right all by yourself with no help, brilliant. If you need a little bit of help, hopefully that will help you the next time you see one of these. Like I said, I think this is the hardest one of these questions I've ever seen. But very cool, very creative question. I really enjoyed getting my teeth into this one. All right, let's look at part B. We need to keep moving here. That was a very hard part 1, by the way. Let's look at part 2. It says calculate the maximum mass of malachite that will eventually be formed from this mass of azurite. So what they're talking about is the mass of azurite that we just figured out. And they want to know how much malachite would be formed from that. Okay, so if you think you can do that, pause the video and have a go on it now. So this is part 2. Pause the video, have a crack at it if you think you can do that. Okay, if you need a little bit of help with it, let's figure out what the conversions are that we need to do here. Okay, so if you need a bit of help, well, first of all, it told you what's the maximum amount of malachite that will eventually be formed from this mass of azurite. So we're starting with a mass of azurite, and that is the mass that we just figured out. So we're going to say grams of Az, right? And that's azurite, what we just worked out in the previous question. And we want to go to grams of malachite. And of course, we can't do that without going through moles first. So we need to go from grams of azurite to moles of azurite. Then we go from moles of azurite to moles of malachite. We call them mal, M-A-L for malachite. And then finally, once we have moles of malachite, it's easy to go to grams of malachite. And that would be our final answer. All right, now that I've helped you with that, pause the video and see can you do the conversions. I suggest you do it the same way I did above, unit analysis. That's why I love it so much. It always works. Pause the video and have a go. All right, so again, we're going to set it up using unit analysis. And I never go to the calculator until you have it on paper. That's my rule. Okay, so let's see. What are we starting with? We're starting with grams of azurite. And we're converting to moles of azurite. So what's my first conversion factor? If you weren't able to do this by yourself, let's go do it together. Pause the video and write down what units on top, what units on bottom. Okay, the first thing you should have done is obviously we're going from grams of azurite to moles of azurite. So we want grams of Az on the bottom, so they cancel. Remember, anything over itself is 1. So we're essentially dividing grams of azurite by grams of azurite, and that gets rid of that unit, turns it into 1. And that leaves us with moles of azurite on the top. Good, so that's the first conversion done. We're doing the second conversion then. Pause the video and figure out what's on this fraction, what's on the top, what's on the bottom. Pause the video. Okay, what you should have done is you should have said, okay, well, we need to cancel our moles of azurite and leave us with our moles of malachite, or malachite, or whatever it's called. Mole of malachite. Good, there's the second conversion done. And remember what we want our final answer to be is grams of malachite. So let's set it up and convert from moles of malachite to grams of malachite. Pause the video, write down the conversion factors, the units on this fraction. Pause the video, do that now. Okay, so we'll go from mole of malachite on the bottom here, they cancel, and look, the magic of this is we're left with grams of malachite, the only unit we know we're going to be right here. So our final answer is going to be in grams of malachite. Good. Now let's now put the numbers in. First of all, going back to our previous example, this was the mass of azurite that we were talking about. So what was it? Sorry, I underlined it and never looked at it. 6.89. 6.89. 6.89. All right, so now what's the relationship between moles of azurite and grams of azurite? Let's do that now. Pause the video and figure that out. All right, so for every 1 mole of azurite, we have this big long thing up here. Okay, this mass of azurite for every 1 mole. Now, I'm not going to write it all out like that. Again, that was just to show you how we did it. When you figure that out, and you should have done that again there, what you're going to get is that this number is 344.5. This here is the MR of azurite. The next bit is we want to know how many moles of azurite for how many moles of malachite. Now we're going to have to go back to our equation for this. So I'm going to show you the equation again and the molar ratio. Pause the video and write down the numbers there that are required. All right, so hopefully you can see that there are 2 moles of azurite for every 3 moles of malachite. That's what we're putting in over here. 2 azurites for 3 malachites. And lastly, we need to know how many grams of malachite is there in a mole of azurite. So if this is 1 mole, how many grams of malachite is there? So again, I'm going to show you the formula for azurite because you might need to know that to figure it out. Pause the video and figure out that. Okay, so what you need to do is find the MR of malachite, this thing here. So if you aren't sure, that's what you're doing now. All right. And again, you should only be playing the video now if you figured out how many grams of malachite there are in a mole. And the correct answer here is 221 grams. So that's what you should have got. If you didn't get this number, then we added up something wrong, or we multiplied something wrong, or I'm not sure exactly what you've done because I can't see your work. But remember, this 3 doesn't matter when we're working out MR. It's just the MR of all this stuff that I've underlined here. 221 is the answer there. So go ahead and plug that in your calculator, see what you get. All right, so this is the correct answer. It should be 6.63 grams of malachite is what you could, is the maximum you could produce if you started with 6.89 grams of azurite. Fantastic. Right, let's move on to the next bit. Okay, look here. It says what volume? So we're going to molar volumes here. Measure that STP. Now, the first thing I want you to do is think about STP. What is the volume of a mole of gas at STP? That's the first thing you have to know. Pause the video and write that down. I always put that in above my STP up here. What does this mean? Pause the video and write it down. Okay, so the first piece of information, 1 mole of any gas at STP is 22.4 liters. So there's 22.4, I'm going to write that down, 22.4 liters for 1 mole. Okay, now at room temperature, that number will be different. It will be 24, but at STP, it's 22.4. So what is the volume of STP at STP of carbon dioxide that would be released from the painting in the formation of this mass of malachite? Okay, so look what they're starting us with. They're starting us with mass of malachite that we just worked out in the previous question. And they want to know what is the volume of CO2 that could be produced here. So if you think you can have a crack at this, let's go ahead and we can pause the video and have a little go at that now. This is part 3. I'll put it back so you can read the question. Pause the video and have a crack at this now. All right, if you knew when you were able to do it, fantastic. If not, and you need a little bit of help, let's think about the conversions here. All right, first of all, we've got a certain amount of grams of malachite. That's what we're starting with, grams of malachite. And we want to go to vol, or liters is volume, liters of CO2 at the end. Now we can't go straight from grams to liters. We must first go through moles. So we've got grams of malachite. We need to convert to moles of malachite. Once we have moles of malachite, we can convert to moles of CO2. And then once we have moles of CO2, we can go to liters of CO2. That should help you a lot here to work through what the conversions are. Let's go ahead, pause the video and write down, have a go at this now. All right, so again, if you weren't able or if you got stuck anywhere, this should help. We're going to help you with the unit analysis first. So we're beginning with grams of malachite. We're converting from grams of malachite. First conversion here is grams of malachite to moles of malachite. So these are our two units that need to be in this fraction. Figure out which one is top, which one is bottom. Pause the video, write them down. Right, you should have had grams of malachite on the bottom. We can cancel out the units there and leave us with moles of malachite. We're now going from moles of malachite to moles of CO2. So what we're going to do is we're going to set up that conversion. All right, and we're going to figure out what units on top, what units on bottom. Okay, so we should have gone moles of malachite to moles of CO2. Finally, we're going from moles of CO2 to liters of CO2. Sorry, that should be red. Keep it consistent. To liters of CO2. Again, one last conversion. How are we going to do this? Pause the video and write down. Oh, sorry, I never cancel out my units. Okay, my previous ones, moles of malachite, mole of malachite, I've still got, and now I've converted to moles of CO2. I need to convert from moles of CO2 to liters of CO2. All right, so pause the video, write down what units are on top, what units are on bottom. Right, so what we should have done here is moles of CO2 on the bottom. They cancel with those moles of CO2. And what do you know? I'm left with liters of CO2. And that's great because that's what I wanted in my final answer. So when I've worked all this out, it's going to be a certain number of liters of CO2. Fantastic. Let's put the numbers in. What was the mass of malachite? Well, it was what I worked out in the previous example. It was 6.63 grams. Okay, so 6.63 grams. Pause the video and put in the rest of the numbers here, please. All right, so hopefully you figured out that for every 1 mole of malachite, this was, let's go and cheat and see what we did up here. Well, we've seen the MO of malachite here was 221. So let's use that again. We don't need to work it out again. 221 grams of malachite for every 1 mole of malachite. All right, conversions. Moles of malachite to moles of CO2. You are going to need this here. Sorry, I never showed you this to help you with it. Pause the video, fill in that third conversion. Aha, so here you can see 3 moles of malachite for every 1 mole of CO2. All right, so put that in. 3 moles of malachite for 1 mole of CO2. Last one, for every 1 mole of CO2, how many liters is it? 22.4. Easy peasy. All right, stick this whole sum in your calculator and you get the number of liters of CO2. Pause the video, do that now. All right, so what you should have got is 0.224 liters of CO2. Fantastic. All right, a really cool question, I have to say. Really challenging, but really rewarding when you get there. Last little bit, look at 1 marker. I don't know if I've ever seen this, 1 mark on the chemistry exam, but anyway, not giving it too much value, but it's saying suggest a way that further deterioration. So we want to stop the painting deteriorating anymore of the painting by this chemical reaction could be prevented or delayed. Now you could try and guess this, or you could use the information that you've been given. Just going to go part 4. How do we prevent deterioration? If you think you can have a guess at this already, pause the video and write it down. Now, if you want to use the information you've been given, let's go up and look at what's actually going on. Let's look at the actual reaction again. I'm going to rub out all this stuff now. I want you to focus on the chemical reaction, the balanced equation. How can we stop this reaction from happening? Really look. It's very simple. Pause the video and write down an answer. How can we stop it from happening? What you should have been focused on, what I was trying to help you figure out here, is to focus on this reaction and see that this is the problem. We've got Azurite in the painting. That's just part of the painting. That's fine. But the reaction that's making it turn from this to this is the Azurite is reacting with this. Now that I've given you that clue, pause the video, write it down. All right, obviously we need to find some way of stopping water mixing with the Azurite. Okay, number of ways you can do this. Keep it dry. Try and keep it dry. Keep water away. Keep it dry. That's the first way we do it. Now, in an art gallery, that might be something like, there might not be people throwing water on it, but maybe the humidity is too high. So as well as keeping it dry, you could maybe use a dehumidifier. fire, or control the humidity, you could say, fire. Another thing you could do is you could actually paint the whole thing with clear varnish, and that would keep the moisture out. Now, you might not actually, I'm not sure about that particular chemical. Maybe the varnish might react with it. It's still a suggestion though, okay? So paint with clear varnish. Those are 3 reasonably sensible suggestions, okay? Depending on the paint, you might not be able to use the varnish, but they can't really, they kind of have to give you the marks there because you have made a suggestion. That's all they ask you to do. All right, guys, that's it. I hope you actually enjoyed the challenge of that question. Really, really nice one. Not easy, difficult, but for those of you who get this, who are able to follow a unit analysis, you should be able to work out this type of question. You should actually enjoy it. Okay, right, guys, that's it. I'll see you in the next one where we'll do another couple of stoichiometry problems. All right, that's it. Good luck.